All right, ladies and gentlemen, I'm back with some fun math problems to do. We all love math problems. That's why you're here, right? So I'm going to do two different problems that are distance equals rate times time problems. Okay, so the first thing that we have to understand and recall is that their equation is distance equals rate times time. Okay, so I'm going to look at this problem. Flying against the jet stream. So first we have to understand that against the jet stream means the wind is going against us. It's trying to slow us down. It's pushing us. It's slowing us down. So going against the jet stream, a jet travels 7,000 miles in 7 hours. Flying with the jet stream, so when you're going with it, that means the wind is back and it's pushing the jet and it's making the jet go faster. Okay, so then with the jet stream, that same jet travels 6,200 miles in 5 hours. What is the rate of the jet in still air, and what is the rate of the jet stream? So this is actually can be set up quite easily. Okay, so if we look at this, we have distance equals rate times time. Okay, so my first distance is 7,000. Okay, my rate, I don't know what it is, but I know that the rate of the plane is being slowed down because I'm going against the jet stream. Okay, so I'm going to call the rate of the jet J, and it's being slowed down, so it's going to be a minus S, and I'm calling S the jet stream. So J equals the rate of the jet, and S equals the rate of the jet stream. Okay, down. So my total rate of the moving object is going to be what the jet wants to do in still air minus the jet stream, which is pushing against me. And we know the time was 7 hours. It says we went in 7 hours. So we call this equation 1. Okay, so now I'm going to look at what my second equation is, because that was against the jet stream, and now with the jet stream, my distance was 6,200. And now the jet stream is pushing me. So the rate of my jet plus the jet stream is making me faster. Okay, and my time there was 5 hours. Okay, now the fun thing about this, if we do these problems right, we actually can save ourselves a little bit easier. Okay, so normally you would see a multiplication over here like this, and you might say, hey, I want to do distribution. Well, in this case, I don't want to distribute. Okay, I'm going to divide both sides by 7 here and divide both sides by 5 here. I want to get rid of that time. Okay, so equation 1 becomes 1,000 equals J minus S. And equation 2 then, we're going to use our calculator here, so 6,200 divided by 5, that gives me 1,240. And this equals J plus S. Now the nice thing about this scenario now is that I have an easy set of equations to use elimination. Okay, so I'm going to use elimination now. I'm going to add these two together. So 1,000 plus 1,240 is going to be 2,240. J plus J, that's a 1J plus a 1J, that is 2J. And look at what happens to the S's. Minus S plus S. That's 0. It cancels out. Now I have an equation, one unknown. It's quite simple. So now I can divide by 2. And the rate of my jet, remember J over here was the rate of my jet, is going to be 1,120, and that is miles per hour. Okay, so the rate of my jet in still air was 1,120 miles per hour. And now, in order to solve for what the rate of the jet stream is, I just need to substitute. I can use either one of these two equations. That's up to this second one, where I've got a positive S there. So I'm going to plug in my number. So I have 1240 equals the rate of my jet, 1120, plus S. Now I can subtract 1120 from both sides. Okay, that leaves me with S over here. And I've got 0, 2, 1. So the rate of my jet stream is 120 miles per hour, which means it slows me down by 120 miles per hour if it's pushing me in the face, or it speeds me up if it's pushing me at the back and it makes me go faster. Okay? And so that is going to be what my difference is. Okay? So my jet is 1,120 miles per hour, and my jet stream is 120 miles per hour. Okay? So that is, we're going to have similar problems you're going to have going upstream in a river, downstream, upstream, things like that. Okay, or a cyclist might be going against the river. We've seen problems before where maybe they talk about those moving sidewalks. You see it at airports sometimes, and you know how much faster can you go when you're walking with it versus when you're walking against it. Okay, so this is going to be a very similar setup in all of those types of problems. Now I'm going to do a second distance equals rate times problem that's set up just a little bit different. Okay, so I'm starting with, I've got two buses and they leave towns that are 560 miles apart. So what I want you to see is the picture. So these towns are this far apart. Okay, they are 560 miles apart. Okay, and the buses are going to travel